So hopefully this will work here. Today we're going to take a second look at piecewise functions. So you can turn to what we did yesterday and add in that we are working on piecewise functions. Oh dear, let's see if we can make this work here. And so in your notebook here, make sure you have this numbered at the beginning, what your page is, and then we're going to take this graph and paste it into your notebook here. So we talked a little bit about yesterday how there's 3 different pieces here. So the way we're going to write this is we're going to start with f of x equals, and then we're going to have our large brackets here, and then we have to figure out what are the equations for these lines. Well, I'm going to look at this first one here. This one's pretty easy. This one is y equals 2. This middle one here is a parabola, so we have x squared, and it doesn't look like it's been shifted up or down. And then this line, let's see, slope. If we were to make our slope triangle here, 1 over 1, and if we were to keep this going, our y-intercept would be 2, so that we have y equals 1x plus 2. So our 3 parts of the equation, they're going to go here. So we have 1x plus 2, x squared, and 2. We don't need to write the y equals because we already have that f of x there. And after each of these, we're going to put a comma, and we're going to say when we use this. So let's go back to this graph. Maybe I'll erase that from there. And we're going to reference our x values. So right here is our x value where it switches. So it switches at x is -1. So I'm going to write we use that line when x is less than or equal to -1. Because if I was to just say -3, that's where the line is, -4. Everywhere this way, the negative x values, again we're looking at our x, is when that line is. Well, when do we use that parabola? Well, if we take a look at our parabola here, it is in between -1 and 2. So we can write negative is less than or equal to x is less than or equal to 2. And then this straight line right here, we use it when it's greater than 2. And if you guys notice, there's an open circle there. So we'll just say when x is greater than or equal to, oh, excuse me, since it's just an open circle, it's just going to be greater than 2. So the next thing we're going to do is we're going to take a look at a couple problems here. So in your notebook, we're going to write down a few things. So the first one, or we could call this example 2, is let's say I ask you to graph and I apologize, I'm still getting used to this here, and our equation is f of x equals x squared plus 2 when x is less than or equal to 1, and 2x plus 7 when x is greater than 1. Well, let's see. It looks like we have a parabola and a line here. So one way to graph this is we could make a table. We could make an xy table. And when do we use this parabola? When x is less than or equal to 1. So I'm going to put a 1. What are some values that are less than that? 0, -1. And then when we plug this into our parabola, again we're plugging it into x squared plus 2. Sorry about this again, it's a kind of a mess here. I promise I'll get better at it. 1 squared is 1 plus 2 is 3. 0 squared is 0 plus 2 is 2. -1 squared is 1 plus 2 is 3. And then this other one, we have 2x plus 7. And it's a line. So x and y, And let's see, our boundary point is 1 again, but bigger, so 2 and 3. So when we plug in a 1, 2 times 1 is 2, plus 7 is 9. 2 times 2 is 4, plus 7 is 11. 3 times 2 is 6, plus 7 is 13. Now one thing I'm going to make note of here is these boundary points here. This is just greater, so the line, that's going to be an open circle, whereas our parabola, this one over here, would be closed. And now all we have to do is graph this. So maybe a little ways down here, we can take this and make our graph. Whoops, we'll pretend that I drew those straight on there. And then our line, so when we go back up, or our parabola, 1, 3, so 1, 3, 0, 2, negative 1, 3. And I'll start at the boundary point because we want it when it's less than 1. And we have our parabola there. And then we have 1, 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So way up here is an open circle. 2, 11 would be up here. And then we can connect those as well because we want it when it's greater. So let's take a look at one more here. Let's say we have I don't know why I have so much trouble writing with this. F of x equals, and we have a giant graph here. Let's say we got x squared plus 1, 2x plus 3, and 5. And this top one is when x is less than negative 2. Negative 2 is less than or equal to x is less than 3. And then when x is greater than or equal to 3. So again, we could make these tables here, except we're going to have 3. So we have x squared plus 1, our x and y. We have 2x plus 3, x and y, and 5, x and y. So our values, when it's less than negative 2, so negative 2, negative 3, negative 4, and I'm going to write that that's open there. And we have 2 boundary points here, so let's put in negative 2, another x value in between that 0 and 3, and then when it's 5, we can do, let's see, x is greater than 3, 4, 5. And then these boundary points again, so this one would be closed because it's less than or equal to. This one's going to be open, and then that one's going to be closed. Make this smaller. Maybe this will help. Okay, so when we plug this in, negative 2 squared is 4, plus 1 is 5. Oh, that's much better. Negative 3 squared is 9, plus 1 is 10. Negative 4 squared is 16, plus 1 is 17. And then this middle one, 2 times negative 2 is negative 4, plus 3 is negative 1. 0, 3, plug in 3, 2 times 3 is 6, plus 3 is 9. And then 5. Well, all of these are just going to be 5. So again, we're going to take a look at the graph of this. So our parabola, negative 2, 5, and we said that was open. So 1, 2, 1, 2, 3, 4, 5. We have an open circle. Negative 3 and 10. And again, this one, it's going this way. So we have our parabola. Negative 2, negative 1. We said was a closed circle. 0, 3, 3, 9, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, I apologize again, I didn't leave enough room here. So we have that second one, and then 3, 5. But this one up here, whoops, should be open. So I'm going to put a big open circle right there. And then this last one, 3, 5, 3, 1, 2, 3, 4, 5, 4, 5, and 5, 5, and we could draw our line going over. Now the last thing I want to talk about here is, let's say you were given and you didn't want to graph it, and you were asked to evaluate what f of 10 was. Let me try this once more. We'll see if this works. If you were to figure out f of 10, when we look back at our equation here, well, what domain does it fit in? Is it less than -2, between -2 and 3, or greater than? Well, it's greater than, so we know we're going to plug it into the bottom part. So f of 10 would be 5. If I said f of 1, well, which domain does f of 1 fit into? It's in between -2 and 3, so this one goes in the middle. And if we look at our middle one, 2x plus 3, so 2 times 1 is 2 plus 3 is 5 as well.